So this is section 10.5 still. This is the last couple of examples. This has to do with cryptography. So if you have a message and you want to code that message, you want to make sure that somebody else that intercepts your message can't tell what the message is that you're sending. This is what you would be using. All right, this was huge in World War II. In World War II, the Germans had messages that they were able to encode using a machine called the Enigma machine, and it was considered to be unbreakable. Okay, but they had people working on it all the time, trying to figure out how to decode these messages in a timely manner. So they might be able to figure them out, but it was always like too late before, by the time they decoded the message, the information was too old for them to do anything about it. All right, and eventually they did decode it. There's a whole movie about this called The Imitation Game, about Alan Turing, who is a famous mathematician who did created a machine to go through and do all the different combinations and use logic to try to figure out how to do the code. You also, if you're familiar with A Christmas Story, you guys familiar with Ralphie on A Christmas Story? Mm-hmm. Never seen it?
Yes, I saw it.
Well, in it, he's got this special decoder ring that he gets, and you have to do a certain setting on it, and then he's able to get the message from Little Orphan Annie, and then he's able to decode it. And they don't do a very good job of this because actually, I've stopped it and looked at it, and I'm like, that what they gave for the numbers doesn't match up with what his decoder ring had. That's what a big nerd I am, all right? That I was like actually trying to figure out what it is. Now, their way of doing the message is pretty basic, all right? So it's basically like if you want to have a space, you use the number 0, and then A is 1, B is 2, C is 3, D is 4, E is 5, and so forth. So it's going to take me a moment. I'm going to have to do 26 of these, obviously. I know I didn't skip anything because I came up with 26 letters in the alphabet. So the most basic code you could possibly do is just to assign each letter based off where it is located in the alphabet, which number it is. So P would be 16. Every time you had a P in your message, you would change that to 16. Now that would be extremely easy to decode. Now the way that they did this in the movie is that the two dials rotated. So you would have to do a setting. I think they were like, set your dial to B2. And so basically, in this case, B would be 2. But they didn't have the letters necessarily in order. So every letter on the wheel was assigned a number. But as you rotated it, it changed each time what number was by each letter. But this would be like the most basic code you could do. So if somebody sent you something with this list of numbers, it'd be really easy for you to just use this to translate. But this method I'm going to show you today actually starts off with this, but then it makes it where it is a lot more complicated. And one of the things about these codes is that when you set up the code, when people are trying to break that code, what they look for is repeated numbers in the code. Because if there's a repeated number, then that means that's a letter that appears, it's going to be the same in every single spot. And the most common letter, I believe, in the English language that shows up in words is the letter E. So if you guys play in Wordle, that you want to make sure you pick a word that has E in it somewhere, because it's probably going to be part of most words that you do. So if you play Wheel of Fortune, there's certain letters that come up more frequently than other in the English language. And so those are the things you start guessing. Go, well, I think maybe this number that keeps repeating, I think this is the letter R, and so forth. And you can use that to try to do process of elimination and figure out what is the message that you're dealing with. the nice thing about this code this method I'm going to show you is that the letter E, depending on where it's at, in different spots will be different numbers because we're going to use matrices to code these messages. So we're going to start off with something very simple like Trouble in River City, okay? That's from The Music Man, in case you didn't know. So if you guys are a fan of musicals, Trouble in River City is a part of a song in The Music Man. And what you have to do is if you're going to, you got to figure out what you're going to use to encode it. I'm going to use a 3x3 matrix to encode it, okay? So that means when I break this message down, I've got to break it down into something that can be multiplied by that. So if I'm going to take a matrix, some matrix, and multiply it by that, since this is a 3x3, this has to be a something by 3 for me to multiply them together, right? Based off our knowledge of multiplying matrices together. Well, I'm not interested in trying to make this into some other dimension, so I'm simply going to keep it as a 1x3, which means I would be taking the first 3 letters, T, R, O, and multiplying it by this matrix. But since they're letters, I can't multiply letters times numbers. So that is where this comes into play. Instead of TRO, I would use 20, 18, and 15 as my 3 numbers. That way I have some numbers to put in there to do as my code, okay? So I'm going to have to break this down into TRO, and then the next part would be UBL, and then the next one would be E space I, N space R. So you're breaking it into chunks of 3. Again, this is something that the person you're sending the message to would know. You wouldn't tell anybody else because you're going to get these string of numbers. You're going to code it, and then you're not going to have the brackets there anymore. And the person that receives it, they would decode your message. How do you decode a message once you've created it? Well, what's the opposite of a matrix? We've been dealing with those. It's an inverse matrix. So I'm going to show you also today is that once you have a message like that, how you decode it is by using the inverse matrix. It undoes what you've been doing. Okay, so everybody following what I'm saying so far, I hope. So here are those chunks: TRO, UBL, E space I, N space R, IVE, R space C, ITY. And then I'm going to turn those into 1x3 matrices. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. There must be one more. 7. Okay, so I've broken it down into 7 1x3s. So that I could take each one of these and multiply it by that. So where did these numbers come from? Where did 2018, 15 come from? I showed you that. That's everything is translated from this list. A very simple coding from letters into numbers. So then what you do is you take each one of these. So I'm just going to take one of these, like the 2018, 15, and I would multiply it by this matrix. And then I can do this because this is a 1x3 and this is a 3x3. That's possible to do. When you get an answer, what you're going to get is going to be a 1x3. So you're going to get 3 new numbers. Instead of having these 3 numbers that are easy to decipher, we'll have 3 completely new numbers. And based off this code, even if you have like for example, so E is right. I told you E is pretty common, right? Here's E and here's E. So right now in this, E is 5, and then here's that other E, that's a 5 in this spot. But when we go to code it, because this E is in the first spot and this E is in the third spot, they will actually get coded to be different numbers. So it won't be as easy to tell like that those are actually supposed to be the same letter in my message. So this is what we're doing. So here's that first one times that matrix. So you take this row times this column, you get 3 products, add them up. Take this row times this column, 3 products, add them up. This row times this column, 3 values, 3 products, add them up. And this is the new code. So it said 2018, 15, that chunk becomes negative 52, 10, 27. Okay? And if you continue to do that, take this chunk and multiply it by that. Take this chunk, multiply it by that. This would be my new message. Now, once you get the message like this, you would then take off all the brackets, because you don't want to let anybody that's intercepting your message know how you're coding it. You don't want to give any clues. So it would just be this long string of numbers that you would send as your message. The person at the other end would know what matrix you used to code it, and they would be able to then use the inverse to decode it.